Oh, hello. I didn't see you there. I was just enjoying a fresh glass of Yorkshire water after a very long walk. But I haven't travelled nearly as far as this water has. You'll be interested to know that there's exactly the same amount of water on Earth as there was millions of years ago. It just keeps going round, and round, and round, the water cycle.
Now.
Every day, Yorkshire Water delivers 1.24 billion litres of water from reservoirs, rivers, boreholes and springs. Isn't that interesting? That water travels through over 29,000 kilometres of water main to one of 116 water treatment plants. What's that? What happens at those plants? Well, let's take a look and find out.
Screening. The first phase of the screening process is coarse screening. Here, large metal sieve-like screens remove floating debris from the source water, such as dead woods, leaves, rags, or from runoffs from storm events. A further fine screening of materials then removes the likes of suspended algae and plankton. These are removed by screens with smaller openings. This process is the pre-treatment stage of raw wastewater. All screens are virtually odour-free, easy to maintain and energy-saving.
Clarification and flocculation. Flocculation encourages particles in the chemically dosed water to combine into larger flocks which can easily be removed. Each of the flocculators is divided into two sections with a stirrer in each. The stirrers are variably speed and ensure optimum conditions for flock formation. Clarification flotation. The flotation system is a means by which the flock material produced in the previous stage can be removed from the water as a sludge. This takes place in dissolved air flotation tanks. The system works using micro-aero bubbles that are released at the bottom of the tank. As the bubbles move to the surface, the flock particles stick to these and are floated to the top. The sludge is then skimmed off.
The disinfection process starts with ozonation. It is a stronger disinfector than chlorination. Ozone is created in an electric discharge field or by UV radiation. It is then bubbled up through the water being treated. In addition to disinfection, ozone's oxidizing properties allow it to reduce the concentration of iron, manganese and sulfur to form insoluble metal oxides and elemental sulfur. Organic particles and chemicals will be eliminated through either coagulation or chemical oxidation. It also reduces or eliminates taste and odour problems. The insoluble metal oxides now have to be filtered off.
In the next part of the process, granular active carbon is used in filter beds to remove the byproducts of ozonation, as well as traces of any other substances which may also be found in the water. Just 1 gram of granular activated carbon has a surface area of 2 tennis courts. As the water passes through the carbon matrix in the filters, pores or channels trap small and large molecules which stick to the carbon, leaving the water ready for its next stop on the journey to your tap.
Disinfection further continues by the addition of chlorine. Chlorine is used to destroy bacteria and viruses and prevent the spread of waterborne diseases. Like ozone, chlorine is a powerful oxidizing agent, but unlike ozone, chlorine is effective all the way to the tap, preventing the buildup of slime and algae in the water mains and domestic pipes. UV lamps can also be used to disinfect drinking water, as UV rays penetrate the cell wall of organisms, thus hindering their ability to reproduce.
I know which I prefer.